Hello, welcome. My name is Tarmo Ramel, and I'm here to provide you with a short tutorial on looking at some topographic data using QGIS and some nice georeferenced topographic map sheet data from Ontario. So we're going to start by dragging in a GeoTIFF or a scanned NTS map or National Topographic Series map that has real-world coordinates already attached to it. I'm going to simply use my mouse to drag and drop that map sheet into the QGIS canvas. And you'll notice that it's popped up the map. We can see all of the side materials here that would be on the printed version of this map as well. And we can zoom in. We could use the zoom in buttons, or we can on a scroll mouse sort of scroll in and out and look at different parts of what this map looks like. Bring your attention down here to the bottom. It's got the name of the map. Every map has a name. It tells you sort of a dominant feature, usually a location that is depicted on that map. It tells you here that it's from Ontario, and it gives us the scale. Now obviously as I zoom in and zoom out, I'm changing the scale of how this map is being shown on the screen. But this number here, 1 to 50,000, tells us that if this map was printed at its proper size, then this ratio of 1 unit of measure on the printed map would equal 50,000 of those same measures in the real world. So if I measured something on the map that was 1 centimeter long, then in the real world, that same feature would be 50,000 centimeters long. This also tells us something about the level of detail that we expect on this map sheet, because the data was collected to be represented at 1 to 50,000 scale. If this 50,000 was a much larger number, then we would be able to see a much larger geographic area, but then we would see less detail. And if this 50,000 was much smaller, let's say 500 or 1,000, we would see much smaller geographic area depicted on our map, but we would have the ability to see much more spatial detail. So this helps us orient our expectation as to what it is that we see. And if we sort of pan around on this margin, we see all kinds of important and interesting pieces of information. For example, the contour interval. If we look at the lines on our map, these brown lines, that means that as we move from one line to the next, we gain 50 feet of elevation. Or conversely, if we go from this brown line down to that one, we lose 50 feet of elevation. So these pieces of information on the margins are really important in helping us to interpret what it is that we see on our map. While I have this open right now, we might also see that there are sometimes words printed with a distance along the margin with an arrow. And this simply means that if you were following this road and you continued for 3 more kilometers, you would hit this town here of Mathiaville. So along the edge of the map, we sometimes see more of those things, just to help provide spatial context in terms of what it is that we're seeing on our map. We also have the map sheet number 31E3, and it tells you where this map fits into the larger fabric of how maps are laid out within Canada. And if we zoom in up over this way, we'll see that currently we're looking at this map right here. Bracebridge is shown, and some of the primary features of our map are on here. But what it does is it shows us all of the neighboring maps that touch either an edge or a corner with the current map sheet. So if we wanted to know which map sheet was directly to the north of this sheet, we would have to go and get map 31E6, and it would be the Huntsville map. This way, when you have a study area that happens to be right at the intersection of multiple maps or across the boundary between 2 maps, it's really easy to figure out which other maps you need to fill up the entirety of your study area. So lots of interesting things along the edge. teaching you how to measure coordinates, looking at measures of how north is represented and how we can find north. Lots of things that are sort of beyond today's teaching. So let's go back and see the whole of this Bracebridge map. If we can zoom in on the map a little bit, we can see that we've got water bodies shown in blue. We can see that we've got creeks and rivers as blue lines. We've got these little symbols here which tell us that we've got wetlands. These brown lines are contour lines. They tell us the specific elevation along that line. And sometimes we have index contours where the actual elevation above mean sea level is provided. In this case, if we were on this brown line here, we would be at 1,050 feet above mean sea level. And gives us a nice reference point from which we can then start to figure out what the elevations of other nearby contour lines might be. We'll see that sometimes we've got locations named, they'll be printed on there. We have communications towers. We'll see roads in various colors. These little black squares are buildings. We've got quarries and open pits. The green areas are forested and the white areas are cleared. So as we pan across, we can get an idea of what this environment looks like. These pink or red areas are urban or built-up regions, the red lines being roads, and sort of a lot of the local detail of dense urban areas won't be depicted on maps at this scale. But we know that once you're in this pink area, you're in the town of Bracebridge, and you can expect to be in an urban environment. Some locations will have names. Shopping center, this little flag tells us that we've got a school over here. We've got a community center. We've got churches. We've got a hospital, so on. These things are relatively straightforward. Over here, we've got a golf course and a senior citizens home. Lots of interesting things that we can explore and get a sense of what our environment looks like. However, sometimes we want additional spatial detail, and because all of this map is already aligned with real-world coordinates, what we can do is add a contextualizing base map in behind this topographic sheet for spatial reference. So I'm going to head up here. I've got this option for quick map services, and I'm going to click on there. I'm going to select OSM for OpenStreetMap, and I'm going to choose the OSM standard map. And it's going to draw that in the background. Notice that over here we have the GeoTIFF, the scanned map, shown above the OSM, which means that it draws the lowest level first, the OSM map, and then it draws the scan map on top of it. If I change the order of these by dragging them into a different order, it's now drawing my scanned map, and then it's drawing the OpenStreetMap on top of it, and while the scan map is actually here, we can't see it because it's underneath the OpenStreetMap. If I uncheck the OpenStreetMap, it turns that layer off. We can see that the topographic map sheet is still here, but because it's in the wrong order, it makes sense to put it this way so that we see what's happening. So I'm going to zoom in on sort of Lake Muskoka down here, and you can see that in the background we've got Lake Muskoka that seems to be showing up on the OpenStreetMap, and we see Lake Muskoka here, but what I want to show you is that they're actually spatially coincident with one another. So we can head over to the layer styling, and if this window isn't open, so if your viewer looks like this, we can head over here to select the topographic map sheet, and we can click on the Open Style layer with the leftmost button, and then click down here onto the tool that allows us to play with the opacity or the transparency of the level in question. So currently it's drawing the map at 100% opacity, but we can reduce that to 50% or something even less. And now it allows us to see through that topographic map sheet to see the OpenStreetMap layer underneath. And if we zoom in, we can see, as we play around with this, that now we're seeing more and more of the OpenStreetMap, but now we're putting a little bit of that topographic map sheet back on top. And the two are quite well aligned. If you look at the water to land boundary, it's following right along here on the OSM, or the OpenStreetMap layer, and it's following along in the same location on the NTS map sheet. But if we put them sort of at a level where we can see both at the same time, we can see that that layer lines up quite nicely. Now the locations of the buildings a little bit off, some of the roads don't exist on some of the maps. Now the NTS map is a little bit older. The scale might not allow for all of that detail to be shown, but all in all they agree quite nicely with each other. I'm going to zoom out a little bit and move over to, let's say, Bonnie Lake. And again, if we look at the OSM version and then start to increase the opacity of the NTS map, see that they line up quite nicely in terms of their geographic location. I'm going to head back up over towards Baysville, and I'm going to zoom right down here into Baysville. And again, we've got the OpenStreetMap version. You can see Muskoka Road 117 crossing the water, and we've got this large dam here. As we change the opacity, you can see that the two maps are not in perfect spatial alignment with one another. It looks like the road, Muskoka Road 117 here on the OSM map, goes over here, slightly offset to the north relative to how it's depicted on the NTS map sheet. Now this has to do with a change in projection, and there's a small offset, so they're not absolutely perfect, but they're good enough to draw general conclusions and to make general assumptions about what's going on. So this is a really nice way to sort of explore two different data sets at the same time, playing around with one drawn over top of the other, looking at the details on one data set, looking at the details on the other data set, and then creating something that's a blend of the two to see what one map might contain that the other doesn't. So these are some interesting sort of ways of exploration, and to sort of assess whether or not a map has seen land cover change, whether something has changed through time, or if things have been relatively persistent. And just because I can, I've got this neat new tool that allows me to draw on the screen sort of with this laser pointer and illustrate things like little dams that may exist on tiny little creeks. But again, not really all that important for the message today, but it's a kind of a fun tool. So happy exploring, and we'll be in touch with another tutorial shortly. Have a nice day.